Let theta be an acute angle such that tangent of theta is equal to 4/7. Find the other 5 trig ratios. The first thing I'm going to do is I'm going to put this on the coordinate plane. My starting point is theta. That is the angle that we're starting at. That's always here. Because later on you're going to learn that this is standard position and our angles move in counterclockwise direction. So I have an angle here of a triangle, a right triangle, therefore I can use trig, and this is called theta. So something that I know of this given information is I have tangent. Well, tangent is a relationship between two sides. I have opposite over the adjacent, or I have y over x. Raise your hand if you knew that. Because now I can say, remember we just said it was 4/7. The opposite side of theta is my y-axis, right? Is parallel to the y-axis, so that value is 4. So if you want to label it, opposite, and this is also my y value. Then my x value is 7, my adjacent side. So this is the hypotenuse, and this side is 7. This is the adjacent, and we also call that x because it's right next to or parallel to the x-axis. And this is what my picture looks like so far. Raise your hand if you have that. Well, then all I have to do is I have two sides of a right triangle, then I can just use the Pythagorean Theorem. R squared equals x squared plus y squared. This value is r because if I make a circle, my ugly circle, something like that, right? This is your radius, r. So then my r value we're trying to find equals my x value, which is 7, and then my y value, which is 4. So I have r squared equals 49 plus 16. R squared equals 65. If I take the square root, I get r is equal to the square root of 65. Raise your hand if you got that. And then now I can just go back and write out my 6 trig functions. Now I put that yellow down in highlighter to show that's my starting angle. So I don't have an angle measure. So I'm just going to call that theta. This is my starting point, and now I need to find the 6 trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Remember, I'm writing these just like this because they have a relationship, right? They are reciprocal identities. So sine of theta is my opposite over the hypotenuse, or my y over my r, and then therefore I'm going to get y over r, 4 over, I'm going to write square root of 65 up here. 4 over square root of 65, or if you rationalize that, you'll get 4 over 4 radical 65 over 65. Raise your hand if you got that as the answer. And then if I do cosine, that's the ca, so adjacent over the hypotenuse, which is x over r. So I have 7 over 60 radical 65, and then if you rationalize that, you will get 7 radical 65 over 65. Tangent is going to be opposite over the adjacent, so opposite over the adjacent, which you already have. That was part of your clue, right? If this is one of them, that means you have to find the other 5. So our answer, 4 over 7. And then to use the other reciprocal functions, I can just take my answer and just flip them, right? So I have radical 65 over 4, radical 65 over 7, and then cotangent is just going to be 7 over 4. So given tangent theta equals 4/7, I can find the other 5 trig ratios by drawing a picture, labeling, Pythagorean Theorem, and then using my knowledge of the ratios to find